Okay, so the Pythagorean theorem says if I have a right triangle, like we do right here, then I can use the formula a squared plus b squared equals c squared. We've used this a couple times in the last few days. In this case, I plug in the 6 for a and the 8 for b, do something like 6 squared plus 8 squared equals x squared. And you've already done this for a few days, though. Do this in the calculator. X in this case will turn out to be 10. Okay, today we're going to talk about something called the converse of the Pythagorean theorem. Now this works, the Pythagorean theorem works because we have this rule. It says if you have a right triangle, then a squared plus b squared equals c squared. If I see a picture like this, I can use this formula. But the Pythagorean converse says something different. It says that this is true backwards. In other words, it says that if a squared plus b squared equals c squared works, then it must have been a right triangle. For example, we see this picture, and there's measurements here, and we're trying to figure out if these measurements make a right triangle. So if I randomly pick some numbers here, like 5 and 7 and 9, well, if this is going to be a right triangle, if it's a right triangle, then this formula would work. So we test it with the formula. I'm going to try putting in 5 and 7 in the Pythagorean theorem and see if I get 9. So I do this, 5 squared plus 7 squared under the square root. And if I do this, I'm going to end up with the square root of 74. Which is 8.6. Now, I got this number. This is the correct measurement to have a right triangle. This number right here that I was given does not match it. That means it's not a right triangle. So the Pythagorean theorem here, or the Pythagorean converse, tells me this is not a right triangle because I'm supposed to have 8.6 for the hypotenuse. Instead, it says 9, so it is not a right triangle. Now, the Pythagorean converse tells us more than just whether something's a right triangle. It can actually tell us if the triangle is acute or obtuse or right. For example, the question here is, do these three measurements, 10, 15, and 20, if these are the sides of a triangle, is it a right triangle? Okay, if this is a right triangle, then automatically the 20, this would be the hypotenuse. This is the number we're going to test. This is the number we're going to find out if it's right. This number might be wrong. And the way we're going to check that is we're going to do the Pythagorean theorem with the other two numbers. So I'm going to do the Pythagorean theorem with the 10 and the 15. So we go 10 squared plus 15 squared and take the square root and see what we get. If we plug this in our calculators or otherwise calculate this, we're going to get 18.03, and it keeps going to right here. Now here's what we know right away. These two numbers, these two numbers, this one and this one, do not match. If it was a right triangle, they would match. If it was a right triangle, these numbers would match. So we know it's not a right triangle. However, we also know something else. This number down here that we just calculated, this 18.03, this is the correct measurement for a right triangle. This is the right measurement here, the 18.03. It's the 20 that's wrong. The number we were given that was wrong. The number we calculated is right. The number that we were given, in this case, is wrong. And so we can ask ourselves a quick question about that number. It'll tell us about the number we were given, in this case, the 20, is wrong. Sorry about the bell in the background. Now, we can tell if it's acute or obtuse based on which way it's wrong. Is the 20, the number we were given, is this too big or too small? In this case, we're comparing it to the 18.03, which means this is too big. And if this number is too big, that means the triangle is obtuse. See, if these two numbers here, the number we were given, which in this case was wrong, the number we calculated, which is always correct, if they are the same as each other, then the triangles are right. If the number that we were given is too big, as in this case, that makes the triangle obtuse. If this number were too small, that would mean it's acute. So here are two other problems that we can test just to show how this works otherwise. Here I got the 5, 6, and 7 for the first triangle. Once again, the number we calculate is right. The question is this 7 the correct number or is it wrong? We're going to calculate the right number and see if it matches this. And let's check this. So to check that 7, I'm going to do 5 squared plus 6 squared and take the square root. And if I do that, we get 7.8 blah, 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 something. Now, the number we calculate, the 7.8, that is the right number. The 7 that we were given is wrong. So that number is wrong. The question is the 7, the number we were given, is that too big or too small? 7 is too small, which means the triangle is acute. In the other problem, I have the numbers 6, 8, and 10. So once again, this 10 might be the right number, it might be the wrong number. We're going to test that 10. We do it in Pythagorean theorem. We go 6 squared, plus 8 squared, and take the square root. When we add these up, we're going to actually turn out to get exactly 10. These two numbers match exactly. That means it is a right triangle. So again, I know I've said the same thing about 6 times already, but it's the mistake that most people make. The number you're given might be correct and it might not be. The number you calculate is the correct number. So if the number you were given is too small, that makes the triangle acute. If the number you were given is too big, it means it's obtuse. And if it's equal to your calculations, that means it is a right triangle.